the plan for today. We're going to finish up page 9. You're going to finish up the 5.23 problems that we skipped. I have a packet over here that's got everything. It's a lot of problems, okay? You don't have to get through all of it before we take the CFU. I'm not going to take that packet up at all. It's really just going to be for you. I will post an answer key with work for that in case you want to look at that. But we are going to take a check for understanding at the end. It's going to have solved by factoring, solved by quadratic formula, real and imaginary, and then a little bit of this writing. It might have some, I don't know, we'll see. But and then we're going to grade that at the end. So I don't know if it has this on here, on the CFU. But I know that this type of stuff was on the test. The multiplying with complex numbers, conjugates, all that stuff. So that's where we left off. This will be quick. I'm just going to do a handful with you. But this is about saying, okay, here are your roots. You give me the equation. So like literally everything we've been doing with equations, doing our method, getting to the roots, we're now going to do it all backwards. But it's actually easier to do backwards, I think. So we don't even have like, we have some imaginary, but we also have some real here. So look at number 17. They kind of wrote out words to do here. Instructions. You're going to take the roots that I give you and set them equal to x is always the first thing that I do. Then we're going to go back to factored form. So you're going to, like normally we would get x by itself. We're going to put x back with a number and we're going to have a factor. And then we're just going to multiply that out to make sure that we get an equation in standard form. So it's like literally undoing everything we've been doing. There is a note right here that if you have a root that is a complex number, the conjugate is always a root as well. So we talked about those complex conjugates, and I said this last time. What does it mean to be a conjugate? Complex conjugate.
The opposite of the equation?
They're the, well, okay, let me give you a complex number. 5 plus 7i. What's its conjugate? 5 minus 7i. So when it comes to having your complex roots, remember there's always two of them and they're always a pair of conjugates. So if you know like this is a root, then you know this is also a root, okay? And so that's what that sentence is talking about. And then we'll multiply them to get to standard form. So for number 17, you have roots. These are two reals at -2 and +5. So we're going to set x equal to -2, x equal to +5. This is kind of the first step that is super easy, but I think it like helps people know what to do if you actually kind of write it down. And then we're going to go back to setting this equation equal to 0, and then I'm going to get a factor. So I need to move the number -2. I'm going to move it back over. How do I move it back over here? So I'm going to have a factor of x plus 2. What's my other factor going to be? X minus 5. And then I'm just going to put equals y right here. Because we are finding an equation. This is the factored form equation. But what form did I want you to be in? Standard form. And so we're going to do what we did in unit whatever 4 that we were in. And we're just going to multiply that out. I'm going to put the y equals in the front. So we would FOIL. X times x is x squared. X times -5 plus 2x. We okay if I do that in my head? And then -5 times +2 minus 10. And there's your standard form equations. So that's all it is. Now, we'll talk about with i's. I want to talk about 18 over here with fractions. Star this. Okay? So this time your roots are fractional roots. And that's okay. Those are still real. I'm going to do x equals -1/2. X equals +3/4. So in factored form, I do not want you to have a factor x plus 1/2. That is not how we write factored form with a fractional number in there. So we're just going to have 2 steps to get this back in factored form instead of 1. Yeah.
Would it go to 2x plus 1 then?
Mm-hmm. How'd you do that? So first thing you did. I always say clear out your denominator first. So this is with negatives, keep the negative in the numerator, negative numerator, and then clear out that denominator. This is dividing by 2, so I'm going to multiply both sides by 2, and then I have 2x equals -1, and then I can add over the number. So my factor is, just like you said, 2x plus 1. If you can do that in your head, by all means. If you can kind of see how it's going to work, if you need to write out an extra step like I did, that works too. So with the x equals 3 over 4, I'm first going to clear out the 4 by multiplying it over. 4x equals 3, and then subtract over the 3. So that factor is 4x minus 3. And there's my factored form. So just don't leave a fraction in there. I will count off for that. We want it to kind of be turned back around into that factor. And then we multiply it out. I'm going to put y in the front. 2x times 4x is, okay, so then we have negative 6x plus 4x. What's that?
Negative 2x.
And then we have 1 times negative 3. And there's our standard form. Okay? So not too bad. Okay? You're going backwards, but it's like the algebra is kind of moving forwards. It's easier, in my opinion, because you're multiplying. All right, what do we do if there's i's? Well, we just deal with them. Negative 3i and positive 3i. How else can you write that? Can I write that like this? You can also write it like that. And sometimes, like, if we give you something like this, people are like, they don't understand that that's two different things. You can't separate it out. One's positive and one's negative. Okay, so don't be surprised. Like, these are one and the same. So when I do write this out, though, I do want to write it x equals negative 3i, x equals positive 3i, because there are two. And then I'm going to swoop them back over. X plus 3i is a factor. The other one is x minus 3i. And there's my factored form. And now I'm going to multiply this out. X times x. I'm going to not do this in my head. I'm going to write this out so you can kind of see it. So this will be, when I do the outside, I'll have minus 3ix. Then I'm going to have plus 3ix. That looks weird, but does it matter? What happens to it? They cancel out right there. So again, if you can do that in your head, feel free. But then the last guy is going to be negative 3 times 3 is 9i squared. What do we know I squared is? That's important. I squared is negative 1. So whenever we see that, we want to make sure we replace that. So this becomes x squared minus 9 times negative 1, which is what?
X squared
Plus 9. Which this is a sum of squares. It does not factor. That's why it has imaginary roots right there. So even if you have like these, you start with complex roots, you should still be getting a standard form equation. Like the i's should be I squareds that you replace with negative 1. The xi stuff, that should all simplify out and be gone. And you're going to have like regular looking quadratic equations. I was going to say something right. If I showed y'all how to do I in the calculator, right?
Yeah.
Okay. If you forget to, I don't know if I showed y'all this, because sometimes people forget what I squared is. You can put I squared in your calculator, and it will tell you that it is negative 1. If you forget, or you're like, which one is the square root one? You can't do I will just tell you, again, that it's I. But if you do, you're like, I don't remember what I squared is. You have a calculator. Might as well use it. All right, 20 is I'm going to put a star by this one. This one's a fun one. Same idea. The multiplication's going to get a little bit crazy here, though, because of how it's set up. We've got kind of two parts in our roots. So what are we going to set x equal to first thing? 3 what?
3 plus 2i.
Plus 2i. It's one of our roots. The other one is
3
minus 2i. I said star this. Y'all know what that means, right?
Yeah.
You'll see it again. Okay? All right, so we're doing the same thing. Moving stuff back over, but we have two things to move over, which is why this multiplication is going to get a little crazy. So we're going to have x minus 3 minus 2i, right? Minus. What's the other one?
minus 3 plus 2i.
Plus 2i equals y.
Is it so foil? Foil
It's
water?
not technically FOIL because FOIL is for multiplications. FOIL only works when you have 2 terms times 2 terms. This is a trinomial times a trinomial. And I hate the box so much. But with trinomials, multiplication, binomials and trinomials. I'm actually okay with it here because it just does help stuff stay organized and you can kind of see what's going on. So I am going to do that here. It's really, you're just doing triple distribution, but sometimes that just gets like lengthy. So I'm going to put x minus 3 minus 2i. I'm going to make that vertical. And then I'm going to put x minus 3 plus 2i horizontal. And then I'm going to draw a box, which if I am doing a box and I hate them so much, it really, like I'm only going to do this if I truly think that it helps you stay organized and is worth the time that it takes to fill it in. Because I'm just really anti-box typically. Okay? So watch what happens here. It's going to get a little messy, but you're going to see a lot of things simplifying, canceling out, becoming 0. You're going to have some I squareds. It's all fun. So this first box, x times x is x squared. I'm going to move just through this first column. Negative 3 times x. Negative 2i times x. Ix, xi, they are the same. It doesn't really matter. Okay? Next column, negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. Negative 3 times negative 2i is positive 6i. Y'all see what I'm doing? Just multiplying here. 2i times x is positive. 2i times negative 3 is 2i times negative 2i is I squared. So these weird things, these ix's, I've got a negative 2ix and a positive 2ix. What's that going to become?
Cancel.
0, gone. I've got a 6i and a negative 6i. What's that going to do? 0. And then the only other I in there is this I squared. But what do we know I squared is? Negative 1 times negative 4 means this guy is really a positive 4. We all okay with that? And then we just have to put some stuff together. And our standard form will be, is there anything to combine with x squared? No. What about your two x's? Those combine to be? And then your two real numbers, constants I mean, plus 13. So again, your answers to all of these, even if they start with i's in there, they should not finish. They should be like, hey, these are just our standard form quadratics that we've been dealing with from the start. The only way for us to know that there was going to be an I in there is if we did the discriminant of it. And so, again, this isn't that bad, but it is kind of tedious. But it's just multiplication, so I do think it's a little bit easier. But these boxes should kind of be the same, and then these boxes should also be like terms there. So there's one more question. It just says if negative 2 plus I is a root, what's the other one got to be? Negative 2 minus I. It's conjugate. Okay? So go ahead. It says what are the factors? Swing those all over. Get your factors. And then multiply them out and get your standard form. I'll get the workup for this, but this is the equation. Did you get that? Yeah. Did y'all get that over here? Okay. That's what I had on my notes, but I will get the workup so you can check. You now can do 15, 16, and 17. Okay, Jordan just pointed this out. It says 16, 15. Scribble that out. It's 16 is just your roots are plus or minus 7i. Okay, so 3 separate equations here. Again, this shouldn't take super long. When you are done with those, you can come pick up, like I said, this is a big practice packet. It's a packet. It's got like 21 problems on it. It says just to solve. It doesn't tell you that you have to do a specific method. It does tell you, though, that 9 of them are factorable. Okay? So think about whether you, like, how you know if something is factorable. Just know that I will be specific on your assessments because I need to make sure you can do them certain ways. And you can pick this up when you're done with your homework. I am going to start my 30-minute timer for my children. And table mates, you are not going to hand over your